This right here is what your functions are going to look like. So if you want to highlight that or circle that. This is the general form of the reciprocal function. If you guys want to, you can also draw a little representation of what our graph looks like. So if you could draw kind of dotted lines like this, and then two curves like this. This is what our graph is going to look like for this unit, or for this lesson in particular. And we'll see variations of that for lesson 3. This is what we call a hyperbola. A hyperbola is when you have two separate parts, two curves that are separated in different quadrants with asymptotes separating them. I'll define asymptote for you, but it's these dotted lines. So our shape of our graph is going to look like this. So the reciprocal function, which has the same AHK that we've seen before, it's just in the reciprocal function, parent function looks like this, the 1 over x. Once you start putting transformations onto that, if you want to go right or left, remember h does the right or left. H is with the x, just like we always have seen in other functions. So that goes in the denominator with x. That would be your right left, your up down, just like usual is the k at the very, very end, and then your default number right here. When you guys are working with a reciprocal function, the numerator should be 1 as a default. If it's not a 1, so if it's something other than 1 or it's negative or something like that, that's when your a has changed. That's going to be your reflection, stretch, and compress. So the transformations are going to work the same way for this function. They're just in slightly different positions because this is a new form of our function. Okay, so we still have the same general rules for our transformations, which we'll review when we get down to this little section. Okay? But this is your general form with the a, h, and k there, and this is what the parent function would be. Remember, parent function is when there are no transformations. That's why it's very simple, just 1 over x. So just like last unit, we were remembering the parent function for the square root, cube root, and the cubic function. You guys need to start taking the parent function and kind of imprinting it in your mind, as well as what the parent function will look like. So just remember this is the parent function for reciprocal. Now, reciprocal graphs have asymptotes at x equals h and y equals k. When you have a line, x equals, what kind of line would that be? How would you describe a line if you were to graph it with x equals? It would be vertical, right? So underneath this, I'm just going to write vertical. And if you have a line y equals, how would you describe that? Horizontal. So when we have our asymptotes, which I'll define for you in a second, horizontal, we're going to have 2 of them. We're going to have 1 horizontal and then 1 vertical asymptote. Okay? In order to figure out what the vertical asymptote is, it's just going to be x equals h. It's going to be whatever h is. Do you guys remember what special thing we do with h? When you pull it out of the function, it's the opposite. So that exact same situation happens here. So the vertical asymptote is whatever h is, and the horizontal asymptote is whatever k is at the end. Okay, so we're going to be working with h and k just with asymptotes. So an asymptote is a line that a graph approaches but does not cross. A line that a graph approaches but does not cross. A good word that I use to kind of summarize this idea is boundary. So an asymptote is like a boundary for our graph. So if you kind of think about what I drew up here as a sketch, when I was drawing from left to right, when I go over like this, I know I can't cross this vertical asymptote, so the only thing I can do is bend. And just keep going alongside of it because I can't actually cross it. Same thing up here. If I'm going from left to right as I'm coming down, I know I can't cross a horizontal asymptote, so the only thing I can do is bend and just go along next to it. So for our horizontal and our vertical asymptote, we'll never be able to touch them. That's why our graph is bending. You guys know when you take magnets with the same polarity, I think is the word, and you try to connect them, they'll push each other away, right? It's the same kind of thing with an asymptote, it's pushing the graph away. So your graph is going to get right up next to it, but it won't actually touch or cross the asymptote. So that's why the shape looks the way that it does. Okay? So that's how asymptotes work. Now, a quick review of our transformations, right? Because remember, transformations is our smarter bullets here, so just go ahead and review. So anytime your a is negative, when you have something like you're multiplying times the function, when it's negative, what transformation does that imply? When you have a negative being multiplied. negative A. I guess we've done 2 seconds. Reflect, there you go. When you have a negative coefficient, that's a reflection. Now, just like when we were talking about the cube root and the cubic function, we're not going to differentiate reflections over the x-axis and y-axis because they end up looking the same. So we're just going to call it reflect. Enjoy. What if, disregarding the negative, like you could have the negative or not, whatever, regardless of the negative, if your A, the absolute value of the A, is greater than 1, what transformation would that be if you have an A that's bigger than 1? That's a stretch. What if your A, regardless of the negative, is somewhere between 0 and 1, so it's that small number? It's a compression. This isn't new. We reviewed this at least 5 times, so you guys should know this. Okay? So we have reflect, stretch, compress. Remember, A represents stretch, reflect, and compress. It just depends on the number. So you just have to remember that A is up here. This number up here is where you'll find A. What does H do? What kind of shifts does H do? What directions? Left or right? It's nothing new, guys. It works the exact same way. The inside of the function is just going to be the denominator where x is. So h, which is inside the function, is going to be showing your left versus right. What about k, the number at the end, kind of outside of the function? That's your up and down. So we're still going to have our transformations. They're still going to be working the same way. You just have to look for them in a slightly different position within the function itself. Okay? On that. Alright, so just a quick description of these graphs. So reciprocal graphs have 2 different parts in separate quadrants. If there's no reflection, it should be the first and third quadrant, right? The upper right, lower left. This kind of graph is called a discontinuous graph because it has breaks in the domain and range because of the asymptotes. If you guys remember, in our previous units, we've drawn parabolas, we've drawn polynomials. See, when I drew the parabola, it was 1 stroke of my pencil, right? And the polynomial was 1 stroke of my pencil. That's called a continuous graph. If you can draw it, even a line, if you can draw it, minus picking up for the arrows, but if you can draw the graph with just 1 stroke of your pencil, that's continuous. There wasn't any interruptions. Before our hyperbolas, that's 1, pick up my pencil, 2. I had to pick up my pencil in order to graph the other side. Whenever you have to pick up your pencil, move it, and then put it down again to draw the rest of your graph, that's called a discontinuous graph. There's a break in your graph. And so we're going to see more ways that you can have discontinuities, the things that break your graph apart. But for our purposes in this lesson, we're just considering the asymptotes to be discontinuities. Okay? So these 2 little statements here are going to be really important. So the range and the end behavior are determined by the horizontal asymptote. Horizontal asymptote. The horizontal asymptote is in terms of y because it's y equals k, right? So anything that involves a y, the range, the end behavior, those are going to be determined by the horizontal asymptote. The domain, which is in terms of x, is going to be determined by the vertical asymptote. Because that asymptote is in terms of x again, x equals h. So they're really closely related. So the range and end behavior are dependent on a horizontal asymptote, and the domain is going to be dependent on the vertical asymptote. So keep that in mind. So what we're going to do is we're going to graph these. So our learning targets for this lesson is going to be graphing them, just taking the equation and graphing it, and then also finding the same graphical characteristics that we've done in the past. What's the domain? What's the range? What's the end behavior? What are the transformations? That kind of stuff. We're not going to do increase, decrease. We're just going to stick with the basics here. Okay? So here's a step-by-step process and how you guys are going to graph this. There's minimal use of your calculator. Unfortunately, your guys' handheld calculators do not know how to graph asymptotes. Sometimes they'll do vertical, but they almost never graph horizontal. So using your calculator to visually see the graph is not going to be effective. Desmos is much better. So you can use Desmos as a support, but your handheld calculator is not really going to do much for you besides giving you a table of values. And that's how we're going to be using it in this lesson. Okay? So the first thing you guys want to do is set your boundaries, find your asymptote. So all you guys have to do is find your vertical asymptote, which is x equals h, and your horizontal asymptote, which is y equals k. I will be consistently abbreviating them, VA and HA. So that's what I mean by those. Okay, what is H? No, H should be a number. 0. H is supposed to be down here with X, and I don't see anything. So H is 0. So my vertical asymptote is going to be X equals 0 because H is 0. What's my K? Also 0, because K is supposed to be a number floating here at the end, and I don't see anything, so it's a 0. So my horizontal asymptote is 0. Okay? Once we identify what your asymptotes are, we're going to graph them. You must always graph your asymptotes as dotted lines, because they're boundaries. They're not actually part of the graph. They're not part of the curve. They're just boundaries kind of setting up your graph. So you guys want to use dotted lines. Now, if it's going to be hard for you to see the dotted lines, you can use a colored pencil or a pen or a highlighter if you want. But since I'm using color, it's easier for me. So I have the vertical and the horizontal asymptotes right there at 0 and 0, respectively. So that's the first thing you want to do. Set up your playing field here. The next thing you're going to do is use your calculator to find some nice points that we can graph. Unfortunately, because we're working with fractions, you guys are not going to find a whole lot of whole number points, like round, nice numbers. So you guys will be expected to graph some fractions. The only fraction I expect you to graph are the 0.5, because half is really easy to do on here. Beyond that, I don't expect you to do much. So if you guys, in your calculator, if you have one, or you guys can share with somebody next to you, all you have to do is go into the y equals window and type 1 divided by x, and then second graph. That's how you get to the table of values. Don't look at the picture. I mean, you can if you want to, but it's not going to be that informative. If you hit second graph, you'll see the points. Okay, so what are some points that you guys see in your table there? Okay, so that's a nice one. What's another one? Okay, now those are the only ones you guys are going to find with round numbers. Nice whole numbers. So I want you guys to expand a little bit into the 0.5s. Okay, one more.
2.
Great. So for these graphs, you guys will need to start to graph some decimals, but nothing beyond 0.5. So when I graph, I'm going to have 1, 1, negative 1, negative 1, 2.5, and negative 2, negative 0.5 right there. You guys want to have at least as many points as you can, but at least 2 in each quadrant, if you can manage. Okay? So just these 2 points is not going to do much to tell me what the shape of the graph is. So this is why it's important you guys remember what the parent function looks like. All you guys need to do is go along the asymptotes, bend, go through the points, and then go along the next one. Remember, that's how our graph is designed. It's going to go along an asymptote, and then bend, and then keep going along the next one. Same thing in this quadrant. Along the asymptote, bend, along the asymptote. So this is what your graph should look like. Whatever quadrants your points are in, that's the quadrants where your curves will be in. Then you just have to go along the asymptotes to create these 2 curves. It's relatively straightforward. Just make sure you actually go through the points that you graphed. That's all I expect from you. It's more of a sketch, so you don't have a whole lot of points, but just do the best that you can. Do not actually, I know it's hard for me on the board specifically, if you guys have more control when you're drawing, do not actually touch the asymptote and do not cross it. Just go right along next to it. Okay? That's all you have to do to graph. Very straightforward. Alright, now, analyzing these graphs to find the domain range and behavior and transformations. Okay? Oh, by the way, this is the parent function that I was just talking about at the top. So this is your parent function and what it will look like. Okay? Now, for the domain, what does it look like it's going to on the left? What's the furthest on the left? What about on the right? Okay. So it may appear, you may be tricked into thinking because it goes left forever and right forever, you might be tricked into thinking it's all real numbers. But it's not. It's all real numbers except for one number. What is one number that I did not actually include? 0. Do you guys see how I bent around 0, didn't actually touch it? So when you guys are writing your domain, do you guys remember when we did absolute value and we graphed it on a number line? And we had a graph like this? What do we do to represent this? The U. That's what we're going to be doing here. Whenever you guys have a break, you guys have to use a little U, union symbol, to illustrate that break. So on the left, I'm going from negative infinity until what number? To 0, and then I jump over 0. That's my little gap. And then I keep going towards what? Positive infinity. So this is the structure that you guys are going to use to write your domain and range, actually. So all you guys need to do is know what number is being excluded from the range and write this little jump, and then on you go to positive infinity. Okay? So the only number that's not included is that 0. Yes?
You bracket the 0?
No, because we're not actually touching the 0, so you should only use a parentheses. That's the question. All right, what about the range? What's the only number that's not being included in the range as I'm going down up? What number do I have to jump over? 0 again. So my range is going to look identical to the domain. Yes? It's only identical here because the vertical asymptote and the horizontal asymptote are the same number. Now, I'm only going to ask you guys to do the interval notation. Remember how we usually do both set and interval? The set notation, I'm not too worried about for this unit. If you guys want to, you can write it down just once. The set notation would look like this. You would say it's all real numbers, comma, except 0, where the except 0 is represented with x not equal to 0. This is how you would do the set notation. I'm more interested in the interval for this unit. So for other units, make sure you guys know how to do both the interval and the set notation, but for this unit, we're just going to focus on the interval. Okay? But this is how you would do the set. All right, end behavior. So let's take a look. As x is approaching negative infinity, y is approaching what? So I'm going to look on the left side of the graph first. So as I'm going left, what's the highest value that I can be going towards from my graph? What are options usually for end behavior? Usually positive and negative infinity, right? So I can see that I'm rising. As I'm going to the left, I'm rising, but will I ever be able to get to positive infinity? What's in my way? The asymptote, right? So what is the highest I can actually get to? What's my ceiling? 0. So when you guys are working, I'll never actually get to 0. I'll never actually touch it, but my highest value that I'm approaching is 0 itself. So because the asymptote sets a boundary, it is also going to define our end behavior. It cuts us off. We can't get past it to get to positive infinity. So our highest value is that ceiling, the 0 for the asymptote. What about on the right? As x is going to the right, it is falling. And typically when you're falling, your lowest value is negative infinity. But can I get down there? What's my floor? What's the lowest I can get to on the right? 0 again. So just like I said, there was that paragraph up there. Both the range and the end behavior are defined by the horizontal asymptote. Okay? And then lastly, transformations. What transformations am I doing for the parent function? Am I going left or right any? Am I going up or down any? Is that reflected at all? No stretching or compressing? Okay, so this one would be none. That is the definition of a parent function, is that you don't have any transformations. All right, let's try the one next to it. All right, again, the vertical and horizontal asymptotes are defined by h and k. So let's do the vertical asymptote first. X is equal to h, which would be what? -1. Remember, h is inside the function with the x. You just have to, when you extract the h, it's going to change its sign. Okay? The horizontal asymptote is y equals k. K is that number at the very, very end, outside of the fraction, which is -3. That one does not change sign. Okay, so let's go ahead and graph those. So a vertical at -1 is right here. A horizontal at -3 is right here. So that sets up our boundaries. Right. Next, we're going to go to our calculators. Now, you guys have to be really careful. If you do not have a TI-84, the fancy one where you can create the stacked fractions, you guys have to be really careful how you enter this into your calculator. At this point, I would really just prefer you guys use Desmos, especially when you're working at home. But in your calculator, this is how you would have to write it. -1, you would start with parentheses. -1 divided by, here we go. X plus 1 in parentheses, close parentheses, and then the -3. So you need to have parentheses around the entire fraction part, as well as the denominator part. The entire fraction part in parentheses, as well as the denominator part in parentheses. So make sure you guys are really careful. It's very important that you type it into the calculator correctly. Once you've typed it in, you double check, you can hit second graph. right, these are some points that you guys should see. If you don't see those points, then you did it wrong. You guys seeing those points in your table of values? Hopefully. Okay, so those are the numbers that you guys should get, and those are the ones that you guys are going to graph. So I'm going to have -2, -2 right here. 0, -4. 1, -3.5. Negative 1, 2, 3, and then 2.5. Okay, which two quadrants are my curves going to be in? This one's 1, going counterclockwise. 2 and 4. You're going to see how these 2 points are here, so those are going to be the quadrants that our curves are in now. So when I'm drawing my graph, remember you go along the asymptotes, go through the points, along the asymptotes, through the points, and that's how you actually generate your curve. So wherever the points are, that tells you what quadrant your curves are going to be in. So you just connect the dots with your curve there. So this is our picture. Alright, what would the domain be? What's the one number that's not allowed in my domain? You can visually see, like, what number am I excluding from the domain? What number is an asymptote instead of part of the graph? You guys can speak, right? -1, okay? So for my domain, it's going to be all real numbers except for -1. So I write the structure just like I did in the previous one. It's going to go from negative infinity to positive infinity, but jumping over -1 all the way. It's going to be the same structure every time. The number is just going to change. Then what number do I jump over in the range? -3. Oops, my board's going crazy. Alright, so if you just remember the structure, you can visually see what numbers are being excluded going left, right, and up, down. And you just plug in those numbers. Also make sure besides writing an interval notation, make sure you're able to say it verbally. When you're describing the domain or range in words, you would say it's all real numbers except, and then -1, or all real numbers except -3. So you guys may see questions where instead of notation, they'll describe the domain and range in words, and you guys have to pick which one of those options is correct. So make sure you know how to say it correctly too. Alright, end behavior. As x is approaching -infinity, that means as we're going to the left. As we're going to the left, I see that I'm dropping, but what's the floor? What's the lowest I can go towards? -infinity? -3. Because my floor is -3, I can't go below that. Okay? And then as x is approaching positive infinity, as I'm going to the right, I can see that I'm rising. But what's my ceiling? The -3 again. Remember, the -3, that horizontal asymptote, not only interrupts your range, it interrupts your end behavior. It defines your end behavior. Okay? Alright, now this one does have transformations. What transformations do I have? I do have a reflection. So if you guys remember, our parent function on the left, we're in quadrants 1 and 3. If it's in 2 and 4, there is a reflection. Okay, so this was, and also you can see because it's negative. The negative is a reflection. What else? It went left 1 because remember the H, think opposite of what you would normally expect. So I went left 1, and then what does the -3 do? Down. So you guys need to be able to get those transformations regardless of what the function looks like. They work the same way. Just have to be more careful. Alright, we'll try to get these next two done before class ends. Alright, here we go. What is the vertical asymptote? X equals H. What is H? 2. That number in the denominator with X is the value of H. We use the opposite sign, which is 2. The horizontal asymptote would be Y equals K. What is K? 1. Awesome. So we're going to graph those. So I have positive 2 for the vertical and positive 1 for the horizontal. Again, when you were typing this into the calculator, you want one big set of parentheses around the whole fraction, and another set of parentheses around just the x minus 2 in the denominator. So 2 sets of parentheses. When you type that into your calculator, you guys will get these points. 1, 0, 2, 4, 1.5. Or you should get those points. So I have 0.5, which is this guy right here. Then I have 1, 0, which is right here. 3, 1, 2, 3, 1, 2. 4, 1.5. What two quadrants? Which quadrants will the curves be in? 1 and 3, because that's where the points are. So I just go along the asymptotes, go through the points, then same thing over here. Make sure you draw your arrows on the ends because they do go on forever in those directions. Getting closer and closer to the asymptotes, but never touching them. To infinity. Okay. Who can tell me what the domain is in words? Like I was just describing on that previous page. All real numbers except 2. Okay, so that's how you would express it in words. All real numbers except 2. Now, in notation, we would use our jump structure, right? Negative infinity to positive infinity, but with a jump over 2 in the middle. That's where you have the little union excluding the 2. What about for the range? All real numbers except -1. So I'm going to do all real numbers, but I'm going to exclude -1 with this jump. Oh, sorry, +1. Sorry. Positive. Okay, any questions about that so far? Alright, and behavior, x approaching -infinity. What side is x approaching -infinity? The left. So on the left, I am gradually rising, but what's my ceiling? What's the highest I can approach? 1. The asymptote is 1. So my graph, the y represents my graph, the arrow, which is going towards 1. And then x approaching positive infinity is on the right. I can see that I'm falling, but what's my floor? 1 again. So you guys, there's no like trick where the end behaviors are different. The end behavior should be the same. You just have to remember that the end behavior is the asymptote. That's what you have to remember. But both of the end behaviors should be the same. Alright, what about our transformation? So I can see up here where a is, it's a 1. When it's just 1, that's the default, right? So if it's just 1, that means there was no stretch, compress, or reflect. It's just 1, you're good. What is, excuse me, what is this -2, the x minus 2, what does that do? What transformation? Well, yeah, the h becomes positive, right? So what direction did we go in? We went to the right. Right, too. Remember, transformations work the same way. What about the +1 at the end? Up 1, just like it normally would. Alright, here we go, our last one for today. So this one I actually want you guys to write different. Do you guys see how on this one there's actually a coefficient in front of the x? None of the others had coefficients in front of the x, and that's actually going to be a problem for us. So what I want you guys to do to understand this problem a little bit more is to write it like this. I'm going to pull these fractions apart. I can see that this is really 1/x times -1/2. Kind of like this, I can separate the 2 and the x as their own little fraction, but keep them as multiplication. Doing it this way is going to be a lot easier to see what the transformation is. Okay? Alright, so vertical asymptote. What is h? Is anything being added or subtracted to the x? So then what's h? 0. There's nothing in the denominator being added or subtracted to the x, which is what h would be. That's a 0. What about k? Is there anything at the very, very end? No? So then what would k would also be 0. The h and the k are not there, so they're both 0. So my asymptotes are on the axes again. That was sloppy. Alright. Now in your calculator you guys could either enter it like this, or if you want to keep it the way it is, just put parentheses around the 2x in the denominator. You guys are only going to get 2 points. Because we have that minus 1/2 being multiplied at the front, it's going to make all of our numbers fractions. So unfortunately, we don't have any whole number points. We only have the 0.5 and then more difficult ones. So I'm only going to be able to graph this one and this one. I'm only going to have 1 point per quadrant, but you can still see which quadrants they're in. It's in quadrant 4 and quadrant 2. And you can still graph it. You only have 1 point though, so just be really careful as you're graphing the actual curve. Alright, which number is excluded from my domain? 0. So it's going to be negative infinity, jump over 0. And then go to positive infinity. Sorry, the writing's all spooky. What about the range? What am I jumping over in the range? 0 as well. Because the horizontal asymptote was 0. So I'm going to say it's all real numbers except for 0. Use that same structure. Alright. X arrow negative infinity. What side is that? Left. So on the left, I am falling. I can see I'm falling, but what's the floor? 0. Can't go lower than 0. And then on the right side, I am kind of rising. I'm going up, but what's my ceiling? 0 again. Can't go higher than that. Now, this is where you guys need to pay extra careful attention. I split this on purpose to help you guys see what the transformations are. Am I going left or right at all? No. Am I going up or down at all? No, but I have this negative and this 1/2 being multiplied at the front. What does the negative do? It reflects because of the negative. And then what does the 1/2 do? Compress. Very good. So that's why I wrote it differently, so it's easier to see. Exercise will be seeing what the picture looks like, except for the asymptotes. The asymptotes have not been drawn. We're going to have to figure out where they are just based on how the graph is laid out on the coordinate plane. We're going to find the information. We're going to go backwards. We're going from the picture. We're going to figure out the transformations. We're going to figure out the asymptotes. Then we're going to plug them into the reciprocal general form equation to see if we can generate what the function will be. Okay? So here, I know they haven't drawn the asymptotes, and again, this is why it's kind of not the greatest to graph in your calculator, because your calculator doesn't graph asymptotes either. So you guys have to just see how, based on how the graph is curving, you have to kind of visualize where the breaks would be. So where do you think, whereabouts would the vertical asymptote be, based on how it's bending? -4. So I'm going to go ahead and add that, so it's going to be a lot easier for me. So I'm going to write x equals -4 right here. And then where does it look like it's bending at the horizontal? Around the axes, oops, sorry. So that's about y equals 0. Okay? So with this information, that gets us a good kind of starting point. Remember that your function is going to start with y equals, obviously, so I can write that part. Now the next thing you guys want to figure out is what's going on in terms of the stretch, compress, all that stuff. Because we already know what the h and the k are going to be. The only other transformation we need to worry about is to stretch, compress, and reflect. Okay? So if you guys think really carefully, if you guys turn in your nose back to the very first graph we did, the parent function, what 2 quadrants is the parent function in?
First and then
First and third, right? The upper right, bottom left. Is that also happening here?
Mm-hmm.
Upper right, bottom left? So if that's true, that means that there is no reflection.
So it's just one of those.
Well, we know there's no reflection, so we know it's not negative. Right? In order to determine whether it's a stretch or compress, we have to be a little bit more careful. In order to find A, it's a little bit more complicated, so what you guys want to do is look very carefully at the picture. I want you guys to draw dots at the exact points on the graph. So I see one here, here, and I see one here. What are those 2 points? And -3, 3. Okay? So what we need to do is figure out what A would be. So what I'm going to do is I'm going to write down the equation that we have so far, but use an a for the top number because we don't know exactly what it is. So right now, we have y equals a, we don't know what it is, but because we know the horizontal asymptote is minus 4, what would I write down here? Oh, sorry, yeah, my bad. So x plus 4, and because the horizontal asymptote of the k is 0, we don't have anything added here, right?
Wait, why is it 9? What is
That's an a.
Oh.
A, so I don't know what A is, okay? Now because I don't know what A is, but I need to know what this is, what I'm going to do is I'm just going to write down the equation, but using one of these 2 points, I'm going to plug in those values for x and y in order to solve for A. Does that make sense? It's kind of like what you guys would have done in slope-intercept form, when you're trying to find B. Does that sound familiar from algebra 1? It's just a different setup for the equation. So I'm going to plug everything in with the asymptotes. There's no k because it's a 0. Then I'm going to take one of these 2 points, pick your favorite. Which one's your favorite? Negative 1, 1. So if I plug that in, so that'd be 1, and then a, and then 1 plus 4. Did I put the, oh sorry, that's negative. My bad. Okay, so negative 1 plus 4 is 3, multiply that over 3. So A is 3. So when you guys write your final version of the equation, 3 over x plus 4. That would be my equation. Y equals 3 over x plus 4. So that's how you have to find A. Pick a nice point on here, plug in the x and the y, and then you can find the number. Okay? So that would be my final equation right there. Alright, let's see if we can do it again for our last example right here. Where does the vertical asymptote look like it is resting? Right here. Okay, what about the horizontal? Negative 2. Right up there. Okay, so I have x equals 4, y equals negative 2. Awesome. What's a nice point on here? On either side, either quadrant. Right here? Okay, so I'm going to write that off to the side. Okay, so first things first, let's look to see whether there's a reflection or not. So remember the parent function was 1 and 3? This one's 2 and 4. So this one was it did reflect, so we know that when we write our equation first off, it's going to be negative a up here. And then what would be in the denominator?
X minus 4.
X minus 4 because the horizontal the vertical asymptote was positive 4, so it changes sign. And then what's this bottom?
Minus 2.
Okay, so this is kind of the like skeleton equation, like I was describing the one from last lesson. Now I'm going to need to figure out what the A is by this lovely point that you guys found. So I'm going to plug that in. So I'm going to have negative 1, negative A up here, negative 1 minus 4, and then minus 2. My board is a little bit weird. Okay, so solving this, I'm sorry, that bothers me so much. Why won't let me write correctly? There we go. So what's the first thing you want to do to solve? Okay, so that's a negative 3 in the denominator. Or no, negative 5, sorry. Add the 2. Add the 2 over. Right? And then I multiply the 5, and then I divide by the negative. So what's the value of A? It would be positive 5. So again, I multiply the negative 5 over. They're both negative. Chop out the negative from both sides. I get that A is equal to 5. And so my final equation down here, I'm just going to write over it, should be negative 5 over x minus 4 minus 2. Okay, so again, if you guys want to write down like a list of steps, because we have a little bit of time extra, if you have some room, you can write down a list of steps. First, you guys want to find the asymptotes, right? Second, you want to find a nice exact point that's on there. Third, you want to set up your skeleton equation by plugging in the horizontal and vertical asymptote and the reflection if you have one. And then you solve for A using one of the points. So it's kind of like a 4-step process.